get started? Great. Yeah. So welcome, everyone. My name is Cormac Hogan. I've been here quite a few times before. I'm sure you might have seen me present on various topics. This morning, when Joe was doing his keynote, he mentioned about VMware doing a private cloud, and a lot of the criticism we got about our private cloud is that the fact we didn't have any data services. So we're trying to put that right now, and so that's what the topic of this presentation is all about, is the data services that we're planning to offer, or currently offer, with VMware Cloud Foundation today and going forward into VCF 9 as well. So hopefully that's what you're interested in hearing. Yeah, thank you. Great. So I am putting up a little bit of a disclaimer because we are talking about some of the things that were mentioned at Explore in Barcelona just a couple of weeks ago. And like all those things, yeah, you know, we do talk about vision and so on, but sometimes that never comes to fruition. So just in case, I think they say don't base any buying decisions on what you see here today, is how they put it typically. So this is our agenda. So I will talk about why we're doing data services in the first place. We'll also talk about some of the things, as I said, that were mentioned with data services in Barcelona. And then I'm going to go through some of the architecture of Data Services Manager itself, how it all works, as soon as all these people stop sneaking in. Yes, okay. You're not the only one. And there's three personas that we're focusing on. So obviously the vSphere admin, VI admin, whatever you want to call it, VCF admin even, is one of the main personas. We want to show what we have in store for those particular personas, but also the person who's responsible for deploying or rolling out these data services to the end users. We're calling these data admins. It could be DBAs, it could be whatever. In fact, it could also be the VI admin is responsible for rolling these out too. And you'll see some of the features that we have around these data services which kind of feed into that. And last but not least, what's in it for the end consumers? What's in it for maybe the developers who are consuming these data services, the ones that need a Postgres database or whatever. So we'll talk about those personas, and then I'll talk about next steps and where you can get more information. So this is the challenge that goes on today, and the whole premise behind Data Services Managers to try and reduce the friction between these different personas. So in the first place, you got these end consumers, the app team, we're calling them there in this particular slide. And what do we want that app team to be able to do? Well, we don't want them to file tickets and then wait hours or days to get a database. They want to be able to get these data services immediately and perhaps through self-service. So that's one of the things that Data Services Manager is going to offer. The other thing with the data team, they're the ones responsible for rolling out these data services, but they might be tied up with the traditional commercial databases, the Oracles, the SQL servers, and they may not have the expertise with the new open source cloud native type databases, the Postgres, the MySQLs, and that kind of thing. So can we do something there to allow them to just make these databases available to end users, but with a lot of the common day two operations taken care of automatically? So things like backup, patching, monitoring at a fleet level, not just at an individual database level, but across the whole fleet. So can we do something there? And then last but not least, the VI admins, the infra team, they don't want to see databases popping up all over their vSphere infrastructure. They want to be able to corral these databases, maybe put guardrails around them, maybe control what parts of the infrastructure the databases can be provisioned onto. So I'll show you how we have all of those things covered with Data Services Manager. Okay? So hopefully that kind of resonates and makes a little bit of sense. So the Data Services Managers that we have today, and this is including some of the things that were announced at Barcelona. We brought this product out at the beginning of this year, and it mostly focused on Postgres and MySQL. So a bunch of things we have, you can see them listed here, but I'll go into them in more detail as we go through the presentation. But that has been the bread and butter of Data Services Manager to date, is the provisioning of Postgres and MySQL databases. What was announced at Explore is that we're expanding into the Tanzu portfolio. And I don't want you to get confused and perhaps think that there's a dependency here on Tanzu. There isn't. You don't need any Tanzu. I'll go through the architecture in just a sec and show you that there is no dependency there, but they do have some interesting data services that our customers are interested in, particularly the RabbitMQ for messaging, and Valkey. And Valkey is essentially, if you're familiar with Redis, the in-memory caching system, I think there was a falling out between Redis, the company, and Redis, the open source community. So they actually forked Redis. If you want Redis, you can still buy it off Redis, the company, but an equivalent open source version is Valkey. So those are that was the announcement that we made in Barcelona. And obviously, all of that is sitting on top of VCF. But in fact, what we do offer, or we will be offering, are these 5 services. Postgres and MySQL, you're probably familiar with those, open source, cloud-native databases. We can deploy them standalone. We can deploy them clustered for protection as well. The RabbitMQ and the Valkey announcement, the plan is to embed them eventually into DSM, so you'll get all of the bells and whistles, all of the feature set that we're talking about in this presentation, the feature set that we have for the lifecycle management and patching, the monitoring, the backup that we have for Postgres and MySQL today. We'll eventually do that for these other data services as well. Kind of the outlier then is AlloyDB Omni, which is the on-prem version of Google's AlloyDB. It is another Postgres flavor, but Google have done some extensions to make it, I don't know, I believe it's mostly to do with AI-type workloads or RAG-type workloads. I'm keeping it as a little bit of an outlier. You can see it's a tech preview. There's more work that we need to do with Google to make that fully fledged, embedded into DSM, but it is available today as a tech preview if you're interested in using the on-prem version of that AlloyDB database. Okay. So how does it work? So first and foremost, the VI admin gets a plugin, and that plugin is deployed into your vCenter server, and that rolls out an appliance, an OVA. So the VI admin will roll that out, and then they'll build this structure called an infrastructure policy. And that is essentially how we're guardrailing your vSphere resources, because within that infrastructure policy, that is the container, let's call it, the set of resources on which you can provision your data services. So like I said at the beginning, you won't see these databases popping up all over the place on your infrastructure. You will define the compute, the storage, the networking, where these data services are going to be provisioned. And that is all bundled into a construct called an infrastructure policy, and I'll show you a demo of that in just a moment. So once that's in place, the data services manager itself has a UI or a portal that you can use for provisioning the data services, but it also comes with a full-blown Kubernetes-like API. So you can consume the data services through the UI or through the API. The data team will then come along. Perhaps they've just received a ticket to say, we need to provision a database for an end user. We'll roll out the database. It is using Kubernetes, but it is not a Kubernetes that you as a customer needs to manage. It is something that we are taking care of. We will roll out that Kubernetes cluster from the DSM appliance. Once the Kubernetes cluster is stood up, we have operators. They're called operators. Postgres operator, MySQL operator. We use those operators for standing up the database. And once the database is stood up, you can retrieve the connection string and pass that off to your end user. So this is kind of the traditional ticket-based approach where an end user may file a ticket saying, I want a database, but we also have a self-service approach. And because we have everything guardrailed through the infrastructure policy, because we have features that the data team doesn't need to get involved on, such as automated backup, automated lifecycle management, they can take a back seat here and perhaps focus on the traditional commercial databases, like the Oracles, like the SQL servers, and then we can give the end user self-service to connect to either the portal or the API and provision their own databases. So this will definitely be something that would interest developers, where they don't have to file tickets, but in the knowledge that the resources that you have on your vSphere environment are guardrailed, and similarly, we have features that will do the automated backups, automated lifecycle management of the databases that are being provisioned. Does that make sense? All good? Okay, cool. So we mentioned UI and API, but the Data Services Manager is also integrated into other products. ARIA automation. So we have a custom resource for ARIA automation that you can plug right in and connect to your DSM. And from the service broker in ARIA automation, you can provision databases. If you're using vSphere with Tanzu or supervisor cluster, is that the latest name? I think we call, I don't know, it keeps changing, but hopefully you know what I mean. If you're a consumer of that, there is what we call a cloud consumption interface. And this is where if you have lots of supervisor clusters, this is an element that sits on top and allows you to provision different supervisor services across your vSphere with Tanzu estate. And DSM is integrated there as well. Last but not least, it's in Cloud Director. Cloud Director already has a bunch of extensions around data services, object storage, that kind of thing. But now the feature set that we provide with DSM can also be plugged into Cloud Director. Are there any CSPs, Cloud Director people here? Yeah, cool.
Just a question around Cloud Director.
Yes?
So would it make sense to deploy the plugin on the Cloud Director and by default have the DSM?
Yeah, so the question was whether we should put the plugin, or could we put the plugin into Cloud Director? So it's not something we do today. It still has to be installed on your vCenter server, but what you do is you install an operator, very like the cloud consumption interface, which is able to reach out to DSM and provision databases that way. And actually, I'll show you something later on that comes back to that consumption model on how a remote operator can provision databases on DSM. Great. So again, the benefits for the VI admin, I probably said this a few times already, but that infrastructure policy where you're able to control your resources, control what resources are being consumed for your data services is a big part of it. The second part of it is visibility into these entities that have been provisioned for the data services. So it's not a black box that just pops up, oh, there's a VM, I wonder what that VM is running. What you're able to see is this VM is actually part of a Postgres database. It's actually the primary node in a Postgres database, or it's the replica node in a Postgres database, or whatever the case may be. But we're also bubbling up database-specific metrics into the vSphere client as well. So these metrics can be viewed from the DSM portal, or UI, but we're also bubbling them up into the vSphere client for you to look at. And this just means that VI admins and DBAs, if they're using two different portals, they're able to have the same intelligent conversation about performance or metrics or whatever the case may be. So that's the big thing for the VI admin, plus full integration into, I mentioned ARIA automation, but also ARIA operations and ARIA operations for logs, or more commonly known as Log Insight. So we have connectivity or integration into those three ARIA products as well for VI admins. So this is what the policy is all about. I mentioned that compute resources, so you can select a vSphere cluster, you can select a resource pool, and that's where your VMs that are backing your databases will be provisioned. Similarly, storage policies. I know I'm showing a vSAN storage policy here, but you can use tag-based policies to identify VMFS, NFS. You can also use vVols. All of them are supported. We don't have any dependency on any of the underlying storage that we support. We have this port group, but also a concept of an IP pool, and this is where you set aside a range of IP addresses, and these are the IP addresses that will be consumed by the databases as they are plumbed up onto this port group. So there is a dependency on a distributed port group. It's one thing we have. We could also use NSX, by the way, but that is just one thing to bear in mind. And last but not least, because you're setting aside a set of resources, typically what people will do is try and build the biggest thing possible. So you as a VI admin have control over the sizes of the virtual machines that are being built to back those data services. Now, yes, it's a Kubernetes cluster, and yes, there's going to be some overhead for Kubernetes to run inside in those VMs, but the rest of the resources inside in those VMs will be set aside for the data service. Okay. And this is just a quick view of the dashboard. Like I said, you can. This again is using the VI client, but the same view is available within the DSM portal and the VI client, so you can identify the different types of databases that are being deployed, and you can actually break them out, like expanded here, this PG01. You can actually see what its name is, what's its role. In this case, it's a primary in a Postgres database, and the resources that are being consumed as well. So we have that level of detail now built into the VI client for these data services. So let's have a look at our first demo. The first kicking it off is just to show you the plugin. There's the Data Services Manager plugin. And as I said, once you install the plugin, it also rolls out the OVA, the appliance that's necessary for data services, and it extends your inventory for your vCenter server. So you can see there's some new Data Services Manager stuff in here. And all the stuff I talked about, like the IP pools, the VM classes, that information that goes to build an infrastructure policy is all visible there. So I'm just going to build one very quickly. Compute resources, like I said, could be resource pools, could be a cluster. In this case, it's just a cluster that I'm going to select. I'm going to select a storage policy, one or more storage policies. And in this case, I'm just going to pick a couple of vSAN ones. I'm going to pick one of the port groups, distributed port groups that I have available. And then I'm going to select an IP pool or create an IP pool if it doesn't already exist. And you can see the range that are available there. So I'm going to select one that's already in existence. I'm going to select a VM folder. So this is where the databases that have been provisioned will appear. And then the VM classes. So we have some t-shirt-sized VM classes, the small, medium, large, that we ship with, but you can go and build your own bespoke sizes as well. And there we go. That's my new policy. I'll just give it a refresh to see if it's ready, and it is indeed. And linked within the VI client is a connection that takes you straight to the portal of the Data Services Manager. So you can log in here. You can see there's a bunch of databases already provisioned. You can see the infrastructure policy that I just created, and there's one already in existence. And you can see all of the resources from my vSphere infrastructure being identified here. Now we'll come on to part 2 of this demo shortly, which will be the provisioning of a data service that consumes this infrastructure policy. But the point is, this infrastructure policy now has guardrailed your vSphere resources so that anything that I provision with this infrastructure policy is going to end up on the resources that I've just defined and not just appear popping up all over your infrastructure. Good so far? Great. Okay. So I'll quickly run through this because I mentioned it already. These are just the integrations with the various ARIA products. The one thing I will admit is that with ARIA operations, we've had database extensions for some time. I think we call them integrations now. But the Postgres and MySQL ones were pretty much ignored for the last 3 or 4 years. We hadn't done an awful lot of work with them. As of this summer just passed, we've added some updates to both the Postgres and MySQL. In fact, we've updated a whole bunch of them, but Postgres and MySQL finally got some TLC from the ARIA operations team, and they've done a really good job. And so now we can plug the databases that we're provisioning with DSM directly into ARIA operations. And what's nice is that they're taking a persona perspective as well. So if you go in and look at the dashboards and the metrics from a VI admin perspective, you sort of get a VM-centric view. But if you go in as a DBA, which is the other persona that they've developed these integrations for, you actually start seeing some nice database metrics as well. So I think they've done a really good job here. And I think it's a way that VI admins can maybe assist DBAs who may not be so familiar with the new cloud-native, modern type databases, and assist them with, monitoring and so on. Not an awful lot to say about ARIA operations for logs, other than that we can integrate directly. So this is taken straight from the DSM portal. We can go onto that portal. We can ship the logs directly to our login site, ARIA operations for logs system. Once it's in there, we get metrics not just from the appliance, not just from the DSM appliance. We also get metrics being shipped from the databases, or I should say logging events. So creating, deleting, all of those kind of things, they are also shipped through our login site, ARIA operations for logs. And then, of course, you can build your own dashboards. We haven't built any dashboards ourselves for this or any of these kind of search mechanisms, but there's some blogs and stuff out there that allow you to set that up. If you're not a user of ARIA operations for logs, but you're maybe using a Splunk or Elastic or one of those, as long as it supports syslog over TCP, UDP, or SSL, you're good to go. We can ship the logs there as well. Last but not least, ARIA automation. I mentioned that we had a custom resource. You can download that custom resource directly from the Broadcom's download portal. Once you have it downloaded, there's a README that comes with it. It tells you how to set up the configuration file. Essentially, you're putting in 2 entries. One is for your ARIA automation. The second is for your DSM. You fill in all the details like that into your config JSON. Run it. It is in Python. And once you run it, you go to your service broker, and there is your new DSM entry in the service broker. So it looks something like that by default. We just call it DSM, DB as a service, and then you can just request the rollout of your databases from here. Now, the nice thing about it is that this is just supplied as is, so you could actually modify this to meet your own needs. So for instance, if this is just developers who are using databases for throwaway tests, then there's no need to replicate these things. There's no need to back them up. So you would just close all of those out. If you wanted, because there's some requirement within your company that you have to use a database, Postgres or MySQL of a certain version, then you can hide the different database engines and just offer a single version. So all of this can be modified to meet your own needs. So that was the VI admin. Let's now look at some of the things that the DBA or data admin might get out of Data Services Manager. So there is a bunch of things here that I've alluded to already during the presentation. When you provision a database, we will automatically back that database up for you to an S3 object store that we have a prerequisite of you providing this S3 object store. So it just means that at deployment time, the database will start backing itself up. Second thing we have as well is the self-service mechanism. So rather than a ticket-based approach where tickets are always going to a DBA and then the DBA has to just go through click, click, click or whatever and provision a new database, we can offer end users the ability to provision their own databases. And we have those personas as well for the DSM portal in that we have an admin persona and we have a user persona. And then, excuse me, we have the whole fleet management. So this is the view across the whole fleet of your databases. You're not wondering what VMs or part of which databases or whatever. We can give you that single view of all the databases that have been provisioned through DSM. And in fact, one of the things we're looking at going forward is being able to import existing Postgres and perhaps MySQL databases that exist in your environment, bring them into DSM, and then we'll be able to offer you these features of automated backup and the lifecycle management and so on. So that's some of the things that we have. This is just looking at the governance, security aspect of it. As I said, you can define different personas, admin personas, user personas for DSM as well, and allow the various users to access. We also have LDAP or LDAP-S, secure LDAP integration, not just for the DSM portal itself, but also for the databases. So we allow you to configure the LDAP for the databases as well. There is also API access for this, for Postgres, this thing called pg_hba.conf. What that allows you to do is say, these users are allowed to connect to this database, but only from these clients. So that's what the PG-HBA does. We have full API access for that, so you can tune that as you need it. And all of it comes with a mechanism to install custom certificates, so you can secure the communication not just to the DSM clients, but also to the databases as well. So it's all in there. Just building that out. Oh, yes. So this is the admin view. So you can see you get a whole bunch of different things that you can do as an admin, but then if you're a user, yeah, it's a finite set. Okay, so the database creation, the kind of things that you would go through would be selecting the type of database, the version of the database engine, whether the topology is single node or whether you want it to be clustered, so a replicated database. Username, infrastructure policy then is the next thing. This is the thing that the VI admin built, and hand that off to the consumer of the databases and saying, these are the resources that you're allowed to use for the provisioning of the database. Backups, you could disable backups if you wanted to, but they're enabled by default. Similarly, the maintenance schedule, and this is what defines the automated updates for the databases. So the maintenance schedule is usually Saturday night, Sunday morning. And so when that rolls around, if there has been a patch or an update staged for the database, it will roll it out across the fleet of databases for which that patch is applicable. Okay? I'll talk about that a little bit more later. And then obviously with these databases, there are a whole bunch of advanced options that you can configure. Anything that's supported really by Postgres or MySQL, you can add those advanced options in here as well. It's kind of interesting for ARIA operations in that ARIA operations expects a bunch of additional metrics to be enabled, and this is how you would do that through the advanced options. Cool. This is the backups. As I said, they're enabled by default. You do need a backup location, which is S3 compatible, and you can define the retention period, how long you want to maintain that backup for. This is the maintenance window. As I said, it's Saturday night, Sunday morning. So if you have a patch that has been staged, it'll roll out automatically. So this avoids a data admin or a DBA having to go around each database individually, maintaining them. But it also means that they have a single view of the versions of all the databases that have been rolled out. So there's not going to be outliers popping up that nobody knows what version they are and nobody even knows who's using them, because we have ownership associated with all the databases as well. So this is the patching and upgrading of the data services. So I'm just showing you here that Postgres, some warnings against it. Let's see what it's going to say. Yep, there's a new version available. And you have two options. You can wait for the maintenance window to roll around, and it will apply the patch automatically. But if it's something that's critical, like a CVE or something like that, and you need to get that patch applied straight away, you can also just apply the patch immediately. Yeah. And of course, the appliance itself, similar kind of approach for the appliance. So what we were looking at previously were the databases, but this is the DSM appliance. You can stage an update for the appliance, and again, when the maintenance window rolls around, it'll take care of it, but you can also go ahead and update it on the fly. The big thing about the appliance itself is that it's not in the data path in any way. So your actual DSM appliance could fail, and you might have to restore that from a backup, because we also back that up. But while all that is going on, your databases are unaffected. There's no dependency on having the DSM appliance itself running for the databases to remain online. Yeah, the usual stuff then as well. We have some built-in alerting and monitoring, so you saw some of the warnings previously. You can click on those. It'll give you more information as to what's actually going on. And what we're also thinking of going forward is something like we have in the vSAN health check, where there's the Ask VMware type scenario, so you can click on it, it takes you to a KB article, more explanation about how you might be able to troubleshoot the issue, and so on. We also have some metrics. We saw similar metrics being bubbled up into the vSphere client. As I said, we also have them in the DSM appliance itself. And the other thing is monitoring and alerting. We can send these alerts. They can be emailed, or we have webhooks. So if you're a user of ServiceNow, perhaps, we can ship them out to ServiceNow, or like if you use Slack for notifications, we can send them out to Slack. So it's just standard webhook stuff. Great, so let's have a look at our second demo, and this is the creation of a Postgres database. This is where we left off, okay? So we can see our infrastructure policies. We can see a bunch of databases have already been provisioned. And so what we're going to do now is we're going to create a new database, and this is a Postgres. So we see the various engines that we support. So we're going to pick one of them. We'll give it a name. We'll select a topology. Like I said, it's standalone or could be replicated. Whichever one we're going to do a replication one there. We fill in the database name to match the instance name. We have an admin username. You can set a password. set a DNS. All of that is in there. Now we're going to select the infrastructure policy. So we're going to pick the one that we built in the first part of the demo. You might remember we selected multiple storage policies, so I'm going to pick one of those. Same with VM classes. We had multiple VM classes. Select one of those. We default the disk size to 60 gig, but you could change that to 80 or whatever the case may be. Backups enabled by default. There's only one backup location, which is why it's automatically filled in. And the maintenance window by default is that Saturday night, Sunday morning as well, automatically enabled. Some database options. I mentioned to you I might want to monitor this database with ARIA operations. So I'm going to put in a few advanced options here for the database, which are all to do with statistics coming from the database that ARIA operations can monitor and build dashboards with and so on. So you can put in, there are hundreds and hundreds of these advanced options for the databases, but you can populate whichever ones are relevant to you. And that looks good. We're happy with all of that, so we're just going to go ahead and create the database. It usually takes in the region of, I suppose, 5 to 10 minutes, but we're going to speed things along. And it looks like my database is online and ready, and I can drill in and I can see various things like my replication topology. You can see which VMs map to which nodes in my database. I can see all the infrastructure policy information here. I can see the maintenance window. And the database options that I added previously here as well. So they're all in there. Other things across the top, monitoring. We saw some screenshots of these previously as well. The backups, yeah, it looks like we've already taken a backup. I can generate log bundles, and I have an audit log of all the things that are going on with the database as well. The main thing then is just get the connection string. Now I can hand this off to an end user saying, here's your database, go nuts. And that's what it looks like. You just use in this case, it's the pSQL command line that I'm using, and I'm just looking at some database-y type things. Okay, so that's it. So that is the infrastructure policy part, and now we're building databases, but in the knowledge that the databases that we're building are guardrailed by the infrastructure policy that we created previously. All good so far? Any questions? Okay, great. So I wanted to touch on the end user. Obviously, they will be the consumer of the database. And what we've been talking about so far is maybe a DBA creating a database and then handing off this connection string. But because there's a full-blown K8s API, or Kubernetes API, associated with DSM, we can actually offer self-service to these app developers. And they typically wouldn't want to go through a UI and just do the click, click, click that we saw previously. What they would want to do is create a YAML manifest and just do a kubectl apply and send that manifest to the Kubernetes API server or the DSM API server and build a database that way. And so because we have this Kubernetes API in here, we could describe the database we want in this YAML manifest. The app team would just send it over to the API server. They can download the access through the DSM portal to allow them to connect, and then they can provision their own databases. So we think that for app developers, this is probably what they would want to do. There is another approach, and I think this kind of comes back to the question we had about Cloud Director previously as well, in that you could certainly have VCF all stood up, but you might have environments with Kubernetes clusters that may be capacity constrained when it comes to storage. They may not even have local storage on these remote clusters that can be consumed. And there could be a request or a dependency or a requirement to build a database. What this consumption operator does is it allows remote Kubernetes clusters to request the database to be built on your VCF environment. So we have this concept called a binding namespace, which basically says this user in the app team has the ability to build databases within this infrastructure policy on your DSM. So again, you could have a remote environment. There is no capacity here to build databases, or actually maybe these guys are just going a bit nuts on their local Kubernetes cluster and consuming all the capacity. Okay, we need to put a stop for that. How are we going to do that? Well, we will make them build anything that has a storage requirement, like a database, and soon a streaming service, and other services that we're planning to bring on board. But they're going to build them over on your vSphere infrastructure, but guardrailed by your infrastructure policy. And this is what we're talking about with our consumption operator, and it's a similar concept that we're using with Cloud Director, going back to your earlier question, in that the consumption operator will be installed on Cloud Director, but the request to build databases will be made through DSM. So we think that this could be very interesting as well for remote developers, remote environments that are constrained by storage in some way, or lack of control over the storage, perhaps, is another way of putting it. So great. Yeah, and you can just get the connection string at the end. So that's pretty much Data Services Manager in a nutshell. Looks like I'm finishing ahead of time, which is good, because I know lunch is waiting for everybody. What a ridiculous time to put on lunch, right? While starving. Anyway, a couple of things you might be interested in. I'll leave this up here for a while. I blogged quite a bit recently about Data Services Manager, if you wanted to read up a bit more of it. We do have a hands-on lab as well. Feel free to try it out so you get familiar with building infrastructure policies, provisioning data services, that kind of thing. And if you think this is something that your organization might be interested in, feel free to sign up for an eval. We can have a conversation with you. We actually have resources that can talk you through a POC if you're interested in seeing how it works. And while it is a VCF component, if you wanted to do a POC, you just need a vSphere environment. You don't actually need VCF stood up. There's no dependencies on anything on VCF. So any of the storages, vSAN, VMFS, NFS, they'll all work fine. You just need distributed switches, no dependency on NSX, but it will work with NSX if necessary. And we could just go through the process of getting it stood up. It's just a single OVA at the end of the day. And we just go through the process of rolling out databases and see what you think about it. It also helps us because it's still quite an early stage product, only released this year, so maybe 10, 11 months with this particular architecture. So we're still looking to explore areas where we can expand into, and what data services interest you and that kind of thing. So just while we have a couple of minutes, so Postgres, MySQL, what other databases would people like to see, or what other databases, especially the cloud-native modern type databases, which ones do you use in your environment? Yes?
Arango.
Okay, that's a new one on me. I haven't come across.
It's not a relational database.
Right.
It's a dictionary database.
Okay. So similar to, yeah, okay. I have to admit that's the first request I've had for that one, but yeah, good to hear. Yes?
So, I mean, is there any plans to support commercial databases? I mean, for us, SQL Server's massive. We use MongoDB a lot.
Right.
Obviously, I guess there's open source equivalents to MongoDB.
Yeah.
But it's something we've started noticing as we sort of expand into the cloud from on-premise, using the Azure Database Manager and starting to spin up managed SQL server instances there. So the big one for us would be SQL Server. So is there any plans to have coverage for
Yeah, that's so hold that thought. SQL Server, do you think, would it be beneficial to have some automated mechanism for rolling out Microsoft SQL Server? Raise hands. Okay, yeah, lots of people.
I know what a problem it is. We're heavy users of SQL Server, and the deployment and management of them is difficult when you're doing it at sort of big scale.
So let me ask you another question. Would it matter if SQL Server was deployed as a set of containers, or would it need to be Windows? So for those of you who raised your hands, who would absolutely want it to be deployed with Windows? Oh. And that is the crux of it, right? So your DBAs, if you go to, and you can understand their point of view because, for the last 10, 15 years, they get a phone call at 4 a.m. to say SQL Server database is down. They know exactly where to go looking. Now, if it's a set of containers, which is exactly what they do in Azure, by the way. If you want SQL Server running on Azure, it's a set of containers. So this is a kind of conundrum that we're trying to get our head around, is that if we do offer SQL Server with all the bells and whistles that you saw here about the lifecycle management and so on, would it matter if it was Windows or a set of containers? And you talk to the infrastructure team, which I guess most people are today here, and they'll go, yeah, containers, I don't care. Let's do it with containers. But if you talk to the DBAs, they'll go, no way, Jose.
Is that relevant? Because we're talking about provisioning a service,
Mm-hmm.
a database as a service.
Yeah.
Don't the DBAs kind of get taken out of the equation? And it's a new world, isn't it?
Yeah, yeah.
It's like, as you say, it happens in the cloud, and we're on about VCF putting the cloud on premise, and it's like, hey, it's containers now.
Yeah, so
And for us, the important thing is whether it works.
Yeah.
We wouldn't care if it's Windows or containers.
Mhm.
Is it stable? Is it reliable? Is it performing?
exactly. I think that's what everybody else feels here. It shouldn't matter if it's containers or not. But we've done some sort of roadshows where we invited DBAs along. We've had this conversation, and every time it's, no, not containers. No way.
It's just a DBA though.
Yeah.
It's
But
not
I
like any change.
And I think if you can say that, the SQL Server, is it the suite product that they use for, I probably got the term wrong, but the thing that manages all of their fleet of SQL servers. If you say, well, it doesn't matter. It's still SQL Server. You can still use the same tooling that you're using today. But I think it's what frightens them is that now they'll have to learn Kubernetes. Now they may have to learn containers. How do they look at the logs of something that's going wrong, as opposed to, well, I know it's in, C:/profile/ blah, 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 and I know where to find the registry entries, and I know where to find all of this stuff when it's running on Windows. So it's almost like a mind shift that we have to deal with. That was a very long answer to what you're asking. Are we considering Microsoft SQL Server? The answer is yes, we are, but we want to make sure that we meet the requirements of whoever's going to use it.
But I guess it sounds like it's some way out.
Yeah, not necessarily some way out. I think once we can tie down whether we're going to roll it out as a set of Windows VMs or whether we're going to put it as a set of containers running on the Kubernetes cluster like we do today, once we get that down, I think we'll be very quickly able to get something out there. Great. Yeah. Sorry, you were going to ask.
I was going to say timescale, so
Yeah, I
not a day, but it's months, years.
So what I will say is that there are data services that are ahead of Microsoft SQL Server. So you saw the ones that we're getting over from the Tanzu division. Those ones need to be integrated. We're also looking at doing object storage as a service. So rolling out, whether that will be partnering with somebody like MinIO perhaps or something like that. That's also something that's kind of got priority because so many customers have been asking us for it. But soon after that, I think we're definitely looking at SQL Server. Unless you talk to somebody who will have an NDA with you, the usual kind of thing. I don't think we have a published public NDA, but absolutely we can talk to you about that under NDA. Just reach out. I'm very easy to find, so just reach out to me. Yeah, and it goes for all of you actually. If you wanted to learn more about it, I'm very easy to find on social media, LinkedIn, whatever the case may be. And I think lunch is ready. So thank you very much for coming to my presentation. I hope you found it useful.